All right, folks, Mr. PiP here, and tonight we're looking at something that should make every admiral in the Pacific sleep a little lighter and every rival Navy commander sweat through their uniform. Imagine a 100,000-ton steel city longer than 3 football fields, rising out of dry dock after vanishing from the chessboard for over a year. Not just any ship, the USS Gerald R. Ford, the crown jewel of American sea power, the kind of warship that makes hostile radar operators suddenly remember they have families and vacation days. Now here's the part nobody outside the Navy really talks about. Ships like this don't just go in for maintenance. When the Ford disappeared behind dry dock walls for 15 months, the strategic ripple hit everything from the Persian Gulf to the South China Sea. That's not just a repair story, that's deterrence temporarily blinking. And let me paint the picture the way only a slightly overcaffeinated former military nerd like yours truly can. You're standing in the engineering spaces during post-delivery sea trials. The reactor plant is humming like pure American confidence. Shaft RPM stable. Heat loads normal, then suddenly alarms. Not the polite kind, the kind that makes every sailor in that compartment snap their head toward the status board. One of the main thrust bearings, one of the most brutally important components in the entire propulsion chain, starts failing. Now, if you've never thought about what a thrust bearing does, here's the Mr. PiP no BS version. It's the steel monster that transfers the nuclear plant's power into raw forward motion, turning reactor energy into the kind of propulsive force that can move a floating airbase across oceans. Lose that, and your billion-dollar symbol of American dominance turns into the world's most expensive parking lot. And this wasn't some cosmetic issue. This wasn't chipped paint or a broken coffee machine in the Admiral's ready room. If that bearing had fully let go under operational stress, you could be looking at catastrophic shaft misalignment, severe propulsion damage, maybe even a mission kill scenario at the worst possible time. Imagine that happening while tensions spike near Hormuz, or while Beijing decides it's feeling adventurous around Taiwan. Suddenly, one failed component changes the strategic math for half the globe. That's why the Gerald R. Ford matters so much. This ship isn't just newer than the Nimitz class. It's a completely different animal. Over 1,100 feet of steel, 100,000 tons fully loaded, nuclear-powered endurance, and enough electrical generation capacity to make older carriers look like they're running on extension cords. The Ford can generate roughly 3 times the electrical power of previous classes. And that matters because this is the first American supercarrier built around the future, not retrofitted into it. The Electromagnetic Aircraft Launch System, EMALS, is the headline monster here. Gone are the old steam catapults that basically launched aircraft with the mechanical subtlety of getting kicked by a mule. EMALS gives smooth, precision-controlled launches, less stress on pilots, less wear on the airframes, faster sortie generation, and much tighter launch sequencing. In a shooting war, that means more F-35Cs in the air, more Super Hornets carrying anti-ship loads, more EA-18Gs frying enemy sensors, and more ISR birds feeding commanders the battlefield picture in real time. And let's talk tempo, because wars are won on tempo. The Ford can push up to 270 sorties per day under surge conditions. That's roughly a third more than older carriers. For the average viewer, that might sound like a nice technical upgrade. For a Pacific Fleet commander, that's the difference between suppressing enemy coastal missile batteries in time or watching your escorts eat hypersonic hellfire. So let me ask you guys something right here. Drop your state or country in the comments. If you're watching from Virginia, Texas, California, Florida, maybe even from one of our allied countries out in the Pacific, I want to know, if you were running naval ops, where would you want Ford first? The South China Sea, the Persian Gulf, or parked somewhere that makes Moscow deeply uncomfortable? Now here's where the story gets even crazier. Despite being more capable than the Nimitz class, Ford does all this with hundreds fewer sailors, roughly 600 fewer crew required. That's automation, smart workflow design, improved weapons elevators, better deck movement efficiency, and systems integration so advanced it basically turns chaos into choreography. Less manpower strain, lower long-term cost, more sustainability over multi-month deployments. And then there's the radar suite. This ship sees trouble before trouble even knows it exists. Advanced multifunction radar, volume search integration, simultaneous target tracking, missile guidance, air traffic coordination. The whole thing turns the ship into a floating sensor fusion fortress. In plain English, if something hostile moves within the Ford sphere, there's a very good chance it's already on somebody's screen before its crew even finishes their coffee. Which is exactly why that thrust-bearing failure hit like a strategic nightmare. Investigators later found the problem traced back to machining errors during manufacturing. Tiny flaws, the kind of microscopic weakness that looks harmless in a factory, but becomes terrifying once nuclear-level rotational forces start hammering the shaft line at sea. And this is what makes next-gen military tech so brutally honest. When you push engineering beyond everyone else on Earth, even tiny defects can scale into billion-dollar consequences. The Navy had no choice. Huntington Ingalls had to move immediately. Funds were pushed fast. The carrier was ordered into dry dock, and America's most advanced warship was effectively sidelined, while the global carrier schedule was already stretched thin. Mediterranean commitments, Western Pacific presence ops, Gulf deterrence missions. Every regional commander suddenly had one less ace card. And here's the bigger Mr. PiP question I want you all to think about. If Ford had stayed offline longer, do you think China becomes bolder in the Pacific? Does Iran test Hormuz harder? Does Russia start more aggressive signaling in the Med? If you were the commander holding the deployment board, what would your move be? Because what happened next was somehow even more insane than the failure itself. Getting the Ford into dry dock safely would become an engineering operation so delicate, so absurdly high stakes, that one wrong movement could have twisted billions of dollars of steel and delayed America's naval punch for even longer. So, now the Navy had the problem nobody wants. America's most advanced supercarrier had to be parked, opened up, and repaired from the bones out, without turning a 100,000-ton warship into the world's most expensive monument to bad alignment. This is where the story stops being ship maintenance and starts looking like a Hollywood engineering thriller. Picture the scene with me. Dawn over the shipyard, gray sky, cold river air, tugboats idling like pit bulls straining against the leash. The dry dock is still flooded, waiting like a steel canyon. And slowly, painfully slowly, the USS Gerald R. Ford is guided toward it inch by inch. No exaggeration here. Inches matter. A ship this massive cannot be close enough. One slight drift in alignment, one hull section settling wrong, one support block placed off the engineered load path, and you're not fixing a bearing anymore. You're explaining to Congress why you bent a national strategic asset. Multiple tugboats worked the hull with surgeon-level precision, nudging the Ford into exact position over the block grid below. Underneath that water sat carefully placed keel blocks and side supports, each one mapped to specific structural points along the hull where the ship's weight could be safely transferred once the water drained. This is the kind of operation where naval architects, yard engineers, and tugmasters are basically speaking a language of numbers, stress curves, and silent prayer. Then the draining began. More than 100 million gallons of water had to be pumped out in a tightly controlled sequence. As the waterline dropped, the Ford slowly settled onto the support structure, her enormous hull transferring the load from buoyancy to hard support. Every inch of that descent was monitored. Laser measurements, hull stress readings, shaft line geometry, structural load balancing. If one stern section touched down before another, you risked introducing stress into the very propulsion system you're trying to save. And somewhere in that dry dock, Mr. PiP can almost hear the collective sound of every engineer whispering, "Please lift and settle clean." Once dry, the scale of the operation became almost unreal. The propeller shafts, rudders, underwater hull, and most importantly, the damaged thrust bearing assembly were fully exposed. Specialists moved in immediately, not general mechanics. This is deep-end precision warfare engineering. The damaged bearing had to be removed, the shaft inspected, surrounding alignment checked, and the replacement component installed with tolerances measured in thousandths of an inch. That's the part civilians underestimate. A thousandth of an inch sounds tiny until you realize this shaft system is channeling nuclear power into rotational force strong enough to move a floating city through heavy seas at combat speed. Tiny errors at this scale become giant failures later. And because the Navy hates wasting an opportunity, they turn the dry dock period into a full optimization cycle. Hull inspections, underwater system servicing, component upgrades, additional checks on mission-critical subsystems. If you're already taking the Queen off the chessboard, you might as well sharpen every edge before putting her back into play. Now I want to ask you guys something tactical. If you were the carrier air wing boss, what would be the first aircraft system you'd want fully green-lit after repairs? F-35C Strike Ops, E-2D airborne radar control, or electronic warfare with the Growlers? Drop that in the comments because this is where deployment tempo really starts getting interesting. After 15 months, the shipyard finally hit the moment every sailor and every rival intelligence service had been waiting on: flooding the dock. And trust me, getting Ford back into the water is every bit as tense as putting her in. Massive pumps reversed flow, bringing river water slowly back into the dry dock basin over several days. Slowly is the keyword here. Too fast, and the changing buoyancy forces could create uneven lift, dangerous hull movement, or support block shifts. So the water rose in a carefully choreographed progression, engineers watching every section of the hull as if it were a patient coming out of surgery. Then it happened. The Ford began to float, not dramatically, no cinematic splash, just the slow, almost surreal moment when 100,000 tons of American steel stopped resting on blocks and started trusting physics again, section by section, evenly, cleanly, exactly as planned. That moment alone probably dropped the blood pressure of half the yard. Once the dock water matched the river level, the caisson gate was removed, reopening the path to the James River. Then came the tugboats again, this time guiding the carrier back into open channel with the kind of precision that makes fighter carrier landings look relaxed. And if you've never seen a carrier move under tug control, let me paint it properly. It doesn't sail out, it creeps. Feet per minute. Every shove calculated against current, wind, hull response, and river geometry. A wrong push here could slam steel into concrete and erase months of perfect repair work. Watching Ford emerge from dry dock must have looked like a steel leviathan waking up after surgery. But here's where lesser channels stop the story. Mr. PiP doesn't, because floating is not combat ready. The real proving ground started after the ship touched open water. Fast cruise drills, propulsion load checks, shaft vibration analysis, reactor to propulsion transfer validation, and then the part every naval aviator cares about: deck systems. The propulsion tests came first, naturally. Multiple power bands, heat monitoring, vibration signatures, full load stress. Engineers were laser-focused on whether the replacement thrust bearing would remain stable through aggressive maneuver profiles. Flank speed tests would later push the ship to maximum velocity, forcing the shaft line to prove it could take combat-level punishment. Then came fast cruise, one of the most underrated steps in naval readiness. The ship stays pierside, but the crew runs her like she's already deployed. Communications drills, combat information center coordination, damage control response, flight deck procedure rehearsals, casualty simulations. It's basically a war deployment rehearsal with concrete still visible out of the window. Then the decks started talking. EMALS deadload testing fired weighted sleds down the catapult track, simulating aircraft launch loads over and over again. Every launch cycle stressed the system. Every arresting gear test simulated violent recovery forces. Every readout told the Navy whether the Ford was ready to resume its role as the most dangerous mobile airfield on Earth. So here's my next question for you all. If you were the admiral signing off sea trials, what goes first off that deck after repair certification? An F-35C, a Rhino loaded for anti-ship strike, or an E-2D to rebuild the battle space picture? Because by the time those launches started succeeding, a much bigger question was hanging over the Pentagon. With the Ford back online, where does America send its sharpest naval blade first? And that, ladies and gentlemen, is where this story stops being about a repaired warship and becomes about raw geopolitical gravity. Because once the USS Gerald R. Ford cleared trials and proved that thrust line, catapult rhythm, arresting gear, and combat systems were all back in fighting shape, the question inside every operations center from Norfolk to the Pentagon wasn't, can she sail? It was, where does she change the global equation first? That's the thing about carriers, and especially this carrier. A destroyer sends a message. A submarine creates uncertainty. But a Ford-class supercarrier rewrites behavior before the first aircraft even launches. Her presence alone changes enemy planning cycles, missile allocation models, maritime patrol routes, and political risk calculations. That's deterrence in its purest American form, Peace through the quiet understanding that if things go sideways, the response arrives by sea and by air at the same time. Now put that into today's map. The South China Sea is still crowded with gray zone pressure, maritime militia shadows, and accidental encounters that nobody really believes are accidental. Russia still likes to test NATO patience from the Med to the Arctic approaches. Iran keeps playing dangerous games around choke points where global energy prices can spike faster than a missile warning light. North Korea remains the strategic equivalent of a guy holding fireworks next to a gas station. So when the Ford comes back, it's not just another deployment slot filled. It's the return of America's most flexible answer to simultaneous crises. This ship can stay on station for months, sustain punishing sortie rates, coordinate deep strike, fleet defense, ISR, anti-submarine support, and maritime interdiction without needing permission from anyone's airfield politics. That last part matters more than most people realize. Land bases are useful until a host nation changes its mind, a runway gets cratered, or diplomacy gets messy. A carrier doesn't ask for runway rights, it brings the runway with it. And the Ford brings the best runway America has ever built. With emails, launch precision, reduced maintenance strain on aircraft, improved sortie regeneration, and the electrical backbone to support future systems we haven't even fully seen yet. This ship is less a carrier and more a prototype for the next era of naval warfare. Directed energy systems, more advanced battle network integration, AI-assisted threat prioritization. Ford is the platform future doctrine gets built on. That's why every lesson from this repair matters. The failed bearing was embarrassing, sure. Rivals absolutely took notes. But here's the part that should worry them more. America found the flaw, ripped the ship apart, fixed it, improved surrounding systems, tested everything to the edge, and put her back in the water stronger. That industrial recovery loop, design, fail, repair, adapt, redeploy, is exactly why U.S. military power remains so hard to outpace over the long term. And behind all that steel, all that nuclear power, all that geopolitical signaling, there's still the human element. More than 800,000 man-hours went into this recovery cycle. Think about what that actually means. Welders in tight shaft compartments, precision machinists checking tolerances smaller than a human hair, reactor specialists validating propulsion chain stability, flight deck crews drilling procedures on a ship that couldn't even leave the yard yet, sailors training every day while their home was sitting in dry dock because readiness doesn't wait for perfect conditions. That's the real story of American military strength, not magic hardware, not movie mythology. People, skilled, disciplined, obsessive professionals who know that one bad measurement can echo into a failed deployment halfway across the world. So, let me throw the biggest Mr. PiP question of the night at you. If you were sitting in the Secretary of Defense's chair tomorrow morning, where does Ford go first? Do you send her east, toward Hormuz and the Red Sea, to make sure shipping lanes stay open and Tehran keeps its calculations conservative? Do you push her west into the Pacific, where every gray hull on the horizon becomes a signal to Beijing? Or do you send her into the Mediterranean as a giant floating reminder that NATO's maritime backbone still wears stars and stripes? Drop your answer below and tell me what platform you think changes the naval game next. Another Ford class, carrier drones, arsenal ships, hypersonic sea-based strike platforms? Or does the future belong to AI-coordinated unmanned wingmen flying from these decks? Because this is bigger than one ship. The USS Gerald R. Ford's return tells allies that America's maritime fist is fully clenched again. It tells adversaries that early engineering setbacks don't weaken us. They sharpen the next deployment. And it tells every sailor standing watch tonight, somewhere in the world, that the biggest, smartest, most advanced carrier ever built is back where she belongs, in the fight. I can already picture the cinematic final shot. Sun dropping low over the horizon, golden light washing across the flight deck, crew in colored jerseys moving with practice choreography. An F-35C taxis forward, canopy glowing amber in the sunset, nose wheel locking into the catapult shuttle. The deck officer points forward. The jet launches into the darkening sky. Somewhere far beyond that horizon, a rival commander gets the intelligence update that the Ford is operational again. And suddenly their whole weekend just got worse. If you enjoyed this Mr. PiP deep dive, hit the comments hard. Tell me your state, your country, and your prediction. Which nation tests America first now that Ford is back? China, Russia, Iran, or someone nobody's watching yet? Because the sea never stays quiet for long.